All right, welcome everybody to week 5, day 2. We're going to take a look at some of your dynamic materials that we're due today. And yeah, Donald, that's super cool. I've actually done, I actually have this face tracking app. My dad gave me an iPhone 12 for Christmas for himself because he wanted me to make a YouTube video explaining how to use it to him. I still have it sitting here. It's February. I probably should mail it to him. But in the meantime, I actually have this app that will 3D scan your face, and then you can use that to rig a thing here. So we'll probably do animation later on, but for now we're still kind of in material phase. So animation's a different phase. Your board games are due on Tuesday, so make sure you guys get those, work with your groups in them. If people in your groups are slacking, then I can split them off into their own slacker groups and isolate them from other people. I said in CSI 40 last semester, I created a slacker bracket. So every time people would complain their partners didn't do any work, I put the people that didn't do work together. And then when they would complain their partners weren't doing work, I put them together, and so on and so forth. Okay, so here we have Maswati. Yeah, that's nice. It's cool. Yeah, it's very, very nice. Very nice. I like that. Okay. And so we've got here a parameter controlling color. The lerp, you're not lerping properly here, Maswati. The whole point was to use noise to lerp between the two. So you need to import a noise texture and then hook that up into alpha. Noise textures go from white to black, and then that would create modeled patterns of darker and lighter purple in it. If you don't pass anything for alpha, what you're doing is you're just averaging the two. And so lerp by default, the alpha is 0.5, and so this just, you might as well just have one parameter that is the average value. This is not, you need to hook up a noise channel there. Like, let's say at zebra stripes, white and black, then you'd see stripes of pink and stripes of periwinkle on it. Should be a nicer look. These things probably I would make parameters as well. And so the only parameters here are 2 colors, and it's really just one color. So if you want to redo that by midnight tonight, I won't grade it until then. Here we have the same thing, except you are feeding in the alpha here, and you can see we're getting different colored stripes, and you're also using the RGB as the normal and the red as the lerping. That's, yeah, it works out pretty well, I would say. So you have different areas having different colors on them, and that'll coordinate with the normal node. I'd also probably hook it up to ambient occlusion as well, and I'd probably set these to be parameters as well. Maybe. So a lot of times it's hard to get the specular and the diffuse just right. And the texture coordinate also, I would run a text chord parameter in here as well that would allow you to control the scaling on the texture, because as you make objects bigger and smaller, the scaling gets all screwed up. And so like you can see Stafford's thing here, you can see all the tiling on their texture here. So you can see they have like this repeating pattern over and over again. And anytime you have tiling, the human eye just locks on it. And if it's like a checkerboard, that'd be one thing, but this is not exactly. And so this has different levels of detail, and that's nice. That's a really cool look. I like that. But you didn't post the material nodes, Stafford, so go ahead and screenshot your node graph as well. Oh no, wait, it is there. Never mind. What happened? Okay. Here it is. Never mind. All right. So what do we got here? Occlude you're passing in as a parameter. That's probably not what you want. You probably don't want that as just a single value, because the ambient occlusion is used to detect where ridges and shadows are on it. Just leave it off if you're going to do that. Metallic is a parameter. Specular is a parameter. Grizzling level is a parameter. Okay, I call it roughness, but sure. Then you got the color. The base color is a parameter, and then you've got tiling as a parameter feeding into the UV node there. And you're lerping between green and gray using the texture sample here to pick which whether you're getting green or gray. So yeah, that works out pretty well. You get this nice modeling effect there. Yeah, that looks really nice. It's a good effect. But I think the ambient occlusion is causing this to just look kind of weird and strange. And then you created a material instance of it and changed the roughness and metallic on it. And here you up the tiling. Okay, that's why we were seeing that the tiling over and over again, because you changed it to 30. Okay. All right. So 10 out of 10 for you, Stafford. Well done. Okay. Munkers got pink as the base color, but it's a parameter. All right. Metallic is off. Specular is on 1. That's a lot of specularity. And then roughness at 0.6. Okay, so you're lerping using this noise pattern here. You're lerping between these normal maps and these normal maps. And you are feeding the same tiling parameter in here. Yeah, that's an interesting use of this, because you're going to have different areas with different kind of raised bumps on it, which is kind of interesting. One thing you might do is actually, rather than doing it this way, actually have different texture coordinate parameters for each of the 2 textures, and then what you can do is you can have like a big wave, like sand dunes. You know, you can think of sand dunes, but then have smaller scale structures as well, with like smaller ripples on the sand dunes. And so because these all scale the same way, essentially you're just compositing these 2 normal maps together. You're just in effect creating one new normal map this way. But if you had different texture coordinates, then what you could have is a large scale normal map and a smaller scale normal map, which would be kind of a neat effect. Okay. Is it okay if I turn my material late? My ear's been hurting. Sure. Okay. So we got like a leaf pattern on it or something. All right. Okay. Yeah. Well, okay. There we go. Good. Yeah. So you can see that you got the waves and you got the patterns on top of the waves. Yeah. But I think it'd be neat if you had different texture scaling sizes. You could do pretty neat effects with that. So Munker is 10 out of 10. Good job. Span. Yeah, that's cool. That's a neat look there. Seasonal grass. All right, so we got color 1, color 2 as base color parameters. We got the subsurface color as black. You can take it out if you're not going to use it. It's a parameter. Okay, never mind. Yeah, it's fine. And then you're using the texture sample green channel to lerp between the 2, so you're going to get mottled colors of some darker and lighter greens. That's cool. Multiplying the texture coordinate tiling into here and here. And you're using this as the normal and ambient occlusion, and that will be fine because the colored areas will, yeah, that works out just fine. If you want to make this more interesting, the problem is it looks very smooth, right? Like if you're doing grass is raised and bumpy, and this is a pretty smooth, and you can see it's kind of jaggedy too. Probably because the texture tiling is turned up or turned down, technically, too high, so you can zoom in and see all the details on it. When you could see pixel edges on a texture, it doesn't look good. This looks fine. I would almost say this isn't grass. I'd say this is like a kind of a cool marble effect, or like maybe not marble, but like some kind of stone. You know, like you might see like on a stone bench at a park or something like that. Like I've seen stone look pretty close to that. That's a good look. And the fact that it's really smooth works well for like a park bench or something like that. But for grass, I would probably make it bumpier. All right, good job, Span. All right, Bacalar has a color black to white using this texture sample to basically you're just putting this texture sample on it because you're lerping between black and white using black and white to lerp, and so it's basically going to copy this texture sample onto the base color. But I guess these are parameters, so you can change them, I guess. Param, cool. That all looks good. I would call this guy tiling rather than param. Param's like the default name. Ooh, lerp. No. No. Don't use a lerp node. Use a multiply node. You want to multiply the whatever tiling parameter you have times the texture coordinate, and that will allow you to have a slider that you can drag it around and adjust how much the texture, tiles on it. And I would probably feed that into here as well. So I'd do a multiply node here and run the multiply node into here and here. And your normal map doesn't match up with this, so you're gonna see. Yeah, there you go. So the pictures are basically that black and white pattern there, and then you can see it's got bumps separate from it, which is it's a good look. It looks pretty nice. Looks pretty nice. Yeah, it's solid. Okay. And finally, we got Walker posting a video, Unreal Engine game framework from main to begin play. Okay. Built a new PC with these parts. Okay. Dolan. Ooh, nice. It's a good look. It's a nice look. That looks like it's got some subsurface scattering going on, maybe. What's we got here? Good texture sample. The normal. Okay. 2 different colors as parameters. Okay. And then that. And then did you, Dolan? Did you do a material instance? So you need to create a master material like this, and then you need to right-click it and create a material instance, and then override the parameter values. That was kind of the you'll see something like this, where when you double click on the material instance, you can change the parameters. I did not. Okay. All right, go ahead and do that real fast, Dawn. Or by midnight tonight, let's say. I'll go ahead and give you a 9 out of 10 for now. Okay. Maybe that's not low enough to motivate. I don't know. I'll leave it as a 9 out of 10. But just right-click, make a material instance, and change some of the parameters. It reminds you of the material shading pane of Blender. Yeah, there's like kind of a commonality among a lot of these tools, like Substance Painter. All of them use this kind of node-based system. And it's kind of neat, honestly. Just took multiply filter, yeah. Yeah, it's just it's kind of how it's done. And so when we do coding, you'll see we haven't done much coding yet, but using blueprints, it's the same node-based system, and you can drag and drop bits of code around and things like that to do your programming. So you don't need to bust open Visual Studio like Walker put in his link there. You can simply drag and drop and connect things, and it's a similar node editor. Same interface, alt-click to cut things and stuff like that. Waifus. I don't know. I dig this background. My face is kind of in the way, huh? Let's see. How about that? Yeah. I dig it. It's like, looks like they're in Hakone or something like that. Hakone. Drinking some tea. Yeah. I dig it. My mood changes based on, I don't know. Yeah, very relaxing, exactly. Okay. So, waifus. Here's another one I like. Ooh, it's audio responsive. No. Screen dimming off. Thank you. So it was brightening and dimming based on the audio, and no. Okay. So yeah, I dig this one too. All right, so let's go ahead and fire up Unreal Engine, and we're gonna do a little bit more with landscaping and swimming and materials today. And then we'll maybe move on to coding as well. I'd like to get into that. What the hell just happened there? engine. Yeah, this is pretty cool. And I'd like to do animations and rigging with you guys. I used to go down to the Olympic Training Center in San Diego and do mocap with Olympic athletes. Not for video games, but just the athletes wanted to see themselves in 3D. You know, like you do a javelin throw or whatever. You want to, you know, when you do a throw, you think you know what you did, but then you go back and you watch the video and you're like, oh, my elbow was down when it should have been up or something like that. I'm not a javelin thrower, I can't tell you. But what we did was kind of like the next step. This is like 10 years ago that I was, yeah, I guess we did it more recently than that too. Like starting about 10 years ago. It was just kind of a fun hobby. And so I'd go down there with 3D cameras and they would do a throw and we'd capture a point cloud of depth and then we'd reconstruct a 3D skeleton from it, and then we could replay for them the animation showing the joint angles and the rotational velocities and accelerations and things like that as they did a javelin throw or a discus toss or high jump or whatever. And then they could use that as part of their training. It's kind of fun. And so that mocap stuff, though, can be used to rig animations. So what you can do is you could you can get an iPhone 12 and go out to your driveway and have somebody film you as you're like walking around like this, and then you can export that into a BVH format, and then you can import that and use it to animate, you know, your characters in the game. It's very common. If you guys have ever seen behind the scenes of like CGI Gollum, you know, like Andy Serkis, the guy that played Gollum, he would climb around and things like that, and they would film him and do motion capture and turn his motions into animations. So rather than animating things by hand, which is really hard to do and really time consuming, you can simply have an actor act it out. Keanu Reeves did a lot of it for Cyberpunk 2077, and we all know how well that went. Actually, his animations were not the buggy part of the game, usually, except when he T-poses. Sometimes he T-poses and flies off into the sky like Neo from The Matrix. Are you launching? I hear my hard drive spinning. Are you launching? You're launching. Okay. Why did I upgrade my SSD if I still have this on a spinny disk? Man. I need to move that onto my SSD. So I got a new 8 terabyte SSD, and right now it's launching off my 15 terabyte spinny disk. So you can feel the, like I could just hear my hard drive working. All right. So let's go ahead and rebuild the lighting real fast. You have it open. He's just asserting dominance. Yeah, I know, that was great, because like you go into the hardest quest in Cyberpunk 2077. It's the suicide mission. It's the secret ending of the game, and he's sitting there narrating, and the whole time Keanu Reeves is just sitting there T-posing, and just narrating to you as like you're fighting all these waves of bad guys. Yeah, there it is. There's Keanu Reeves T-posing in Discord. It's fantastic. It's fantastic. Cyberpunk Judy was wonderful. Yeah. Do mocap? Let's see. Do you have a question about mocap, Dolan? Do you want to do mocap, or do you want to know what mocap is? I guess. What is that? Yeah, mocap is motion capture. So while that's rebuilding the lighting, I'll just come over here. And mocap is it's fun, and you can hang out with Olympians and stuff. Belly dance mocap. That might be a risky click. Let's see. Lord of the Rings motion capture Andy Serkis. No, that's Circus. Ah. So motion capture is when you have a person in real life acting, and like this, and then you've got cameras on them, and the cameras capture the motion. That's why it's called motion capture. And so sometimes they will wear rigs. It is something called markerless motion capture, which doesn't have any markers on it at all, and used for ages. Okay. And so we could do that. We could do that in this class. It'd be kind of fun, I think. We could probably do a lecture on that. This semester, apparently, I'm going a lot more into the art and animation side than normal, because normally I'm a programmer. You know, I am not an artist, as you could probably tell from the last. What happened here? Oh, my daughter. Oh, my daughter came in here. Look at this. Yeah, she modified this. That's cool. All right. So you can see all the flowers are gone. Yeah, interesting. All right. Yeah, so apparently we're doing more art this semester, but I hope you guys are fine with that. It is an important part of game development. Oh, she put a little. I'm gonna play this. Let's see what she's done here. Material. So you can come out here. So you walk on this glass. You can see the reflections on that. So that's actually something you can do using materials, is put refraction and reflection into your materials. These steps are almost too big to jump up. It's like a giant staircase. Yeah, look at this. That's cool. Good job, bro. All right. So shadows have been rebuilt and stuff like it. So yeah, but we're doing, you know, art's an important part of video game design and video game making. So I modified this a little bit as well. You might see the water is now more watery. I do want to make a material though for that. You can see it looks a little bit better than the glass that I had before. And as you fall down in there, you can see the film grain effect is a little bit less pronounced. I don't know how much of that is coming through the streaming, but you can see the film grain, I toned it down a little bit. And there's still the vignette effect, and you can see the physics are that of swimming. So I'm not touching anything right now, and you can see I'm kind of slowly falling, basic swim physics, right? So, and again, I need to actually modify the landscape so I can get out of there. Okay, so what should we talk about? So we need to do a little bit more with landscaping, and we need to do a little bit more with swimming. So what should we do? Materials, search for glass. Might be easier just to show you how glass works. Double click. Refraction. Okay. So you might notice that on your materials, refraction is turned off. Did you guys see that? Like if we go into grass or whatever, if we go into the grass material editor, you'll see that there is like it's grayed out. Like you can't hook something up to it, right? It's grayed out. And the reason for that is because there are different types of materials. And when you have nothing selected, over on the left-hand side here, you can see, you can edit the overall material properties here. And so this is a surface material that is translucent. Okay. And if you turn off translucency, you make it opaque, you'll see that refraction turns off, right? Because refraction only applies to surfaces that light can go through, right? Let's close this without saving. No saving. I don't want to mess with that. Okay, so glass. So if you want to make a good water texture, I would start actually with glass, right? As kind of the go-to thing. Make it less shiny, probably, and add some water, like ripples to it and stuff like that. Or you can use the water plugin that I told you guys about last time. But let me just go through how refraction works first. So we've got a parameter here for the color of the glass, and then we've got spec and specular highlighting and roughness and opacity, and so that is how transparent the glass is, this is how rough the glass is, and this is how specular the glass is. And if we change these values, like I can change the roughness up to 0.5, you can see that the glass will become a lot more buff, like it's been scratched up. Oh shoot, I don't want to save this one. Let me duplicate class. Do you want to save? No. Let's just duplicate this. Control W, by the way, is the duplicate command. I'll call this build class. Okay. Or I could have created an instance of it, but whatever. Okay, so I just want to modify it by accident. So, you can add normals to it if you want to add waves and stuff like that. It's probably a good idea. But refraction is what I want to talk about today. So, refraction is every time. Do you guys know the difference between reflection and refraction? Ada, come here, girl. Ada.
Yep, come.
Ada, my students need to know the difference between reflection and refraction. What is the difference between reflection and refraction?
Well, reflection reflects the same picture off of a shiny object.
Mm-hmm.
And with refraction, if you put a straw inside of a glass of water, it will look different because if you look at it like this, you will see that the straw is going in here, but the end of the straw looks like it's coming in from there.
That's right. So, which one is, like when light bounces off the water, is that reflection or
reflection?
That's reflection. Okay. And so with reflection, the same angle comes out as comes in, right? But then it's not a perfectly reflected light. You know what I mean, Ada? Mm. So like when sunlight hits water, some of the sunlight bounces off and some of it comes through here, right? And the angle that comes through here is actually a shallower or a smaller angle than what bounces off. Okay? And so this is called refraction. And this is called reflection. And so when sunlight hits the surface of water, some of it will bounce off, and some of it will bend through the water in refraction. And some of the reflection will take place with a specular, which is like a mirror. It bounces off kind of in the same direction as before. And then some of it will just come out in all directions. And so that would be, so you'll get a little bit bouncing this way and a little bit bouncing that way and a little bit bouncing that way. And so that is called a diffuse reflection. So you're going to get a diffuse reflection and you're going to get a specular reflection. Okay. And so when you make a ray tracing engine, or if you turn on RTX, what happens is a ray will a ray hits the water. I'm going to simplify this, but a ray hits the water and then it'll cast usually two rays, one this way, one this way, and it might cast some diffuse rays in different areas as well. And then if there's a mirror underneath the water here, then it will cast another ray that way, and if it's like a bubble, then it'll refract this way and it'll bounce. And so basically when you do ray tracing, it'll actually, whenever it hits the surface, it'll cast usually multiple rays to do a little bit of diffuse lighting, a little bit of specular, and refraction and things like that. So if you have glass, some of it will bounce off, some of it will refract through. If you have like a glass sphere and light hits it, some of it will refract this way, some of it will reflect, and then the thing that refracts can either exit, no, the angle goes the other way actually. Sorry, it'll exit this way. And some of it will reflect, and then the one that reflects can reflect, and then that one can reflect, and each one of these can cast a ray out in a different direction. And so ray tracing can be very computationally intensive. And so they usually limit how many bounces light can do. Usually like one bounce. It'll bounce once maybe and then stop, or maybe twice, or you do one bounce and then the bounce once tries to see if it can see the sun. There's all sorts of like limits they put on it, because imagine a glass sphere. Like light can just sit there and bounce around inside of it, generating infinite rays, right? And so they will constrain how many times light can bounce. Okay. So ray tracing is an interesting thing that we'll probably talk about in IS-50B more than here. But for here, you just need to know this. Actually, we just need to know this. Okay, reflection, refraction. Okay, you guys with me on this? And there's diffuse and specular. Diffuse kind of bounces in all directions. Specular bounces in, like at a mirror. Okay. All right, so let's come back into this glass thing here. And so we've got here refraction. And that is how much light bends through the surface. And so for glass is more dense than water, and so it's going to have a higher refractive index than water. And then this node here is the what kind of makes the light bending work. And so it looks like it's spelled Fresnel. It's pronounced Fresnel for some reason. I don't know why. Maybe it's French or something. Probably. It sounds French. Fresnel. I don't know. Fresno? I don't know. But anyhow, so you got a parameter that controls that and that. These two parameters together. Let's go ahead and just make a. Let me do this. I'm gonna delete build glass, and what I'm gonna do instead is make it an instance of regular glass. So let me do this. I'm going to create a material instance of it. And this I will call build glass. Okay. And then let's just come over here to our zone. And I'm just going to make this object here glass. So you see how hit play. So you see how it's kind of warping the area behind it, right? Like, look at the, do you see the statue right there? See how it kind of warps depending on the angle of the material? Right? Like when you stick a straw into glass and things like that. Okay. So, so build glass, and let's go ahead and double click on this. So we can make the glass, let's make the glass a little bit more visible maybe. Let's make it a hot pink glass. And now let's just make it, let's make it like a light. That's pleasing to the eye. Last lecture we talked about all sorts of hideous things. Okay, you see the warping over here too. Right. And so when it's at a shallow angle, you see how it's like very reflective, and then at steeper angles, it's not. You see that? And that's because that's kind of how light behaves, right? When it comes in at a very shallow angle like that, it tends to be very reflective. Okay. So, and so it's warping as light passes through this box. Actually, maybe we can do a sphere. Maybe that. Let's try that. Try out a sphere. Let's scale it up a little bit. So I can click on the center part this time. There we go. All right, too big. All right, so we got a sphere now, and we will drag build glass over it, and then you can see that the edges are reflective and stuff. Okay, so let's edit this and change the opacity so we can drag this up, drag it down, so it can be either see-through, completely see-through, or completely opaque. Let's see, there we go. And so if we're going to be trying to make water or something like that, it's probably going to be a little bit more opaque than glass. Just put it at 0.5. This. Okay. And then the roughness, again, I can make it rougher. And so that took a lot of the shine off. Did you see that up there? So you can see there's a specular highlight right there. You guys see that little dot right there? That's called a specular highlight. It's where the sun is kind of... Like, if you ever seen like a pool ball, there's like a little shiny spot on it. It's a specular highlight. It's where the specular is coming right back at you. And the more diffuse you put in, which is controlled by the roughness parameter, you'll see the specular highlight become wider and weaker as you increase the diffuse reflection on it. And then specular, turn this down to 1. Okay. And then let's play with the refraction levels. You see how it's like warping, like the warping is like crazy. Like, do you guys see that? And if I had turned on RTX on this, it'd be even more realistic looking. You see how that thing is just like, right? And then refraction, it's up to 2, and so I've turned the index of refractivity up to 2 on it, and so it's considered a very dense material now. So basically the denser a material is, the more light refracts through it. And so can somebody look up the index of refractivity for water for me? I don't want to waste class time on it, but you can see that this thing is now really like almost like a lens, right? Like if you've ever seen like a telescope lens, like it's basically behaving the same way with it warping. And if we look through 2 of them, then I don't know if the Unreal Engine will actually handle that very well. But yeah, okay. So it's warping through the sphere, then it's warping through the glass. You can create a cool Bruce Lee Hall of Mirrors / glass lens effect. Kerosene, water is 1.3. Okay. And what is glass? Can you look up the refractive index for like a glasses glass? And so you can do all sorts of like cool effects like that. All right. Okay. .5 for plastic lens. Plate glass is 1.52. Okay. Yeah, so we have it up at 2 right now. So this is a very, very dense glass we have right now. So you can see the warping on it, right, as it refracts through. And then the Fresnel fall off controls kind of like what. Let's see. So it's at 20 right now. Let me turn it down to 10, which is the default. Turn it down to 5. Turn it down to 2, turn it down to 1. You can see more and more of it becomes like a lens almost. Okay. It just passes light kind of through it. And so you can use Fresnel nodes to do warping and refractivity and stuff like that. And it's a cool effect, you know, like it does look neat. So let's say we want to make this into water. Damn, you know what? I'm going to go back and duplicate it again, force delete. Yeah, sure. So these guys are going to have their materials removed from them forcibly. Eventually. Any questions for now while this thing is updating? I kind of want to remake this with RTX on, right? Oh, look at this. This thing's not rotated properly. Rotation 0, 0, 0. Okay. And hit end to drop it to the ground. Okay, so I am going to duplicate this, actually, because I'm going to do something a little different. and let's add a normal map to it. Interesting. Huh. Okay, so let's add a normal map to it. And texture sample, holding down T and clicking gives you a texture sample. So let's see if we can find a good normal map for water. Got all these plant things in here. Maybe we'll do this. Snap it to the side, come up into Zach noise here. See if we can find some good. See if we can find some good normal maps. Actually, this is noise, not normal maps. That could be kind of fun though. Let's use this. Color. Let's have one default color be white. And then let's Control W to duplicate. And let's have another color be like that light blue that we kind of liked there. That's periwinkle. And then we will lerp between them using the texture sample that I thought I dragged in, but I guess I didn't. Or maybe it was there and it just didn't update. Let's drag it in anyway. There we go. And then hold down L and click, and it will lerp. So let's have, we're going to create a modeled pattern, right, of like waves, like kind of zigzag waves of lighter and darker colors on this. Let's see how this works out. And then we can find, while that's processing, let's find a normal map that'll work. Starter content. Textures. Find a good wave-like water. Yeah, okay, there's a water normal. All right, that'll work. I guess I don't need one note so much. Put that back. And let's apply. It doesn't seem to be wanting to do a preview. Okay, there we go. Bill glass I'm going to drag into the bill folder. Here. And then bill glass I will put on here and on here. So you see how the glass now has kind of a more uneven surface, right? It looks a little bit better than just like a plain flat, you know, thing, right? You guys see that? Okay. Come back in here, and maybe we can make this a little darker. Actually, it's the opacity. Let's turn the opacity down a little bit. Shaders are updating. You guys have any questions about it so far? All right. So Now we're getting somewhere. Okay. Now we're getting somewhere. Let's make this a little darker maybe. So let's go with like a dark blue. There we go. It's a little too dark. It's a little too cartoony. There we go. That's a nice blue watercolor, right? Is it not lurking between these properly? Looks like it's just coloring the whole thing. Huh, why is it coloring the entire thing? It should be... Got a kind of a periwinkle, we got a white. We're lurking between them. Oh, you know, it might be the text chord. Let's try that. Are they named the same? Yes, they are. Good spot. Okay, so you will be color 1, and you will have the privilege of being color 23. Color, nope. Color 2. And all right. It's not running quickly today. I don't know what's going on. Okay, there we go. Now we're getting some modeling. Okay, cool. So, yeah, good spot on that one. There we go. Yeah, all right. That's nice. All right. And maybe we can find a different noise pattern that looks a little bit better than that. Here. Zac noise. Yeah, water caustics for sure. So caustics are not acid. Caustics are the names for the light patterns that you get when you have, you know, like you have a pool. Have you ever seen a pool and there's like those sharp and darker areas beneath the pool and they kind of move around and stuff like that? Those are called caustics. So now, if we apply it, there we go. Now we're getting somewhere. All right. Then we'll do another one of our multiply nodes. This is going to be tiling. And we're going to drag from you into a multiply node and feed you into the texture sample. So we can control how much it tiles. Tiling will default to 1, 1. That's fine. The tiling parameter default value will be 1, min of 0.1, max of 10. And we will feed the result of that into the bump map as well, or do we want to have a separate bump map? Just feed into it for now. Just see if that works out. And yeah, let's just start with that. Okay. All right. So let's come on over here and see if we can start using this for our water and see, because that's kind of what we're getting at here. Is, like I told you guys last time, we want to make a. Oh, I've already got a Kearney map. Build glass. There we Okay, see that's way too big, right? That's way too big. So I want to control the tiling parameter here, and I'll just have it default to 4, let's say. There we go. It's a little bit better. Now, wouldn't it be kind of cool if these things like moved, you know? I think that'd be cool. What do you guys think? Would it be cool? And if you want, you could have a high frequency and a low frequency noise on it, so you have different patterns of water, because there's usually like bigger ripples and smaller ripples and things like that as well. So let's see if I can remember how to do this. Panner. Okay. Panner. Probably want to do a vector parameter as well. Here. Hearing my hard drive just chugging. I really need to switch this over to my SSD. And so what the panner, there we go. So what the panner node does is it moves the texture sample over time. And so I could also drag this into here. And then the bump map will also move up and down. Yeah, the water is zooming. That is true. Let's get it to chill out a little bit. All right, so let's set it to 2 and 0.5. There we go. It's still pretty fast. 0.5, 0.5, a little more chill. 0.1, 0.1. There we go. 0.05, and you can change the direction also, you know, -2, it'll move in the other direction. 0.05, there we go, nice and slow, nice sedate water. If we play it, shaders are still compiling, there we go. So you can have a nice little animated water surface, and if you get close, you can see there's actually waves in the normal map. The normal map actually has the normal map's actually animating as well, and you can also see really you can actually see the things beneath it. Kind of. Come on. Still need to fix the landscaping down here. There we go. Okay. There's the ball bouncing off. You can see the reflections of the ball, right? And you can also see the terrain. I don't know if you guys can see that too well, but you can see the terrain through the water, and it's doing refraction on the terrain. And then the parts that are really shallow in angle, it's perfectly reflective. And the bump maps, you can see the bump maps are actually animating along with the so the surface of the water is actually kind of moving up and down very, very slowly. And the bump map is moving as well. So the areas that are up and down are actually moving as well. And so that's using the panner node. And you can set a parameter that controls the speed. And yeah, so that's pretty cool, I think. Maybe I should turn down the opacity a little bit. Let's see here. It's a little bit too opaque. Let's turn it down to 0.4. Apply. All right, any questions about that? So, like basically setting up the Fresnel node is a bit of a there's a lot of different parameters, and you know why is it 10 and why is this 1.4? Well, that's the refractive index, but what do these things mean? It's best to just start with an existing Fresnel node. There we go. So it's a little bit more transparent now. You guys see that? So I think that looks pretty decent. And then if you want, we can add a second layer on top of it, so you can have high frequency noise and low frequency noise on it. What do you guys think? Or do you want to get to painting on the landscape? We got like we got half an hour left, so right now the water is just one texture that's kind of sliding on the surface like this, which looks okay. It looks okay, but water doesn't exactly look like that, right? If you ever see like a pool, there's always these bigger waves in the pool, and then there's actually smaller waves that are kind of going in a different direction, right, on the pool. And so what we can do is we can get another set of these things. Let's see. Go to exact noise. Find something that kind of looks like water. It's like oil, kind of. Smoke. Zach posted this on the Discord channel, so if you just type the search on Discord, you can download it. Having good sources of noise is actually really nice. It's a nice tool to have in your tool chest. Let's do this one actually. So I'm gonna drag that guy in. Okay, so this guy is gonna be pretty much the same thing, except I'm going to have the texture coordinates be much more highly tiled than this. So I'm going to control W, these guys over here, and I'm going to have this tiling parameter be called high frequency tiling, and this guy is going to be at like 10. The max would be, let's say, 40. And so this guy is going to be much more highly tiled than the other one. So it's going to have a much higher, you see little ripples on the water. And we are going to use that as a lerp. So click lerp. And yeah, we can make a new vector parameter, I guess, just to demonstrate what's going on here. Vector parameter. So this time I'm going to make it just red. Like this, just so you can see the high frequency noise. And I'm going to call this color 3. Oops. Color 3. And this guy is going to be a bright red color. And we're going to use the noise as the alpha. We're going to take the result of this and feed it into lerp, and the result of this lerp is going to go into the base color. Okay. So let's see how this works out. It was not fast today. Okay, so yeah, that seems to work. Saves. If we come down here, you can see that the water is actually looking a lot better now. The noise pattern I don't really like, and that we need to pan it as well. But you can see the ripples from the bigger the lower frequency, the longer wavelength waves. You can see those moving on the surface, and then you can see the areas where we have this higher frequency thing on top of it, right? So these kind of smear patterns are the new thing that I added, and then these bigger waves are the old pattern. And there's areas you can see areas of lighter blue and darker blue kind of slowly moving across them here. And then you can see the unanimated red areas that we just added. Okay. Okay. So yeah, maybe that noise isn't exactly what we want. Let's try. Yeah, maybe I can just drag caustic noise in again, and maybe this will even work. Should just edit this guy. So call you caustic. Ooh, there's a different one. Yeah, let's do that. And so we'll have two different caustic patterns sliding along the surface at different amounts, and we'll make this a different shade of blue. We'll make it a darker shade of blue. And we will do panning with this one as well. And so we will add another panner. And the panner, water speed duplicate. And so this one will be called water speed 2. Water speed 2. And water speed 2 we will have traveling at a different direction, maybe 0.1 and 0. And you will feed into the speed. And the coordinates will feed into here. And the results of this will feed into you. Honest pay for honest work. And then you can probably do the same thing for the normal map, honestly. We can, right now the normal map is making the waves animate, and that's going to be different from the different colors that are going to be animating on the surface. So we can also have the normal map waves also have higher frequency waves moving in like a different direction on it. Okay, so let's see how this works out over here. Ooh, that's a nice effect. Look at that. That looks a lot more realistic, right? So you can see that there's the high frequency noise moving this way, and then you can see the ripples from the other ones moving this way. And that looks a lot better. And then we've also got the waves of the up and down from the normal map. You see, I don't know if the low frequency waves are even that obvious now. So let me make this guy like bright red, right? So you see that? See how there's that streak of water moving, a streak of white that moved this way. See that? So there's a streak of white moving this way. You have the red moving this way, and then you have the blue. And so these three things are interacting in a very interesting pattern that creates. See how these caustics are like moving and changing and things like that. And if we play with the panner a little bit, we could probably. Maybe come up with something. Nope. What happened here? What happened here? It's moving faster that way. Too slow. And then this panner, we can have it move just in the Y direction here. Ooh, that's way too fast. Okay, so you can see there's streaks of light moving this way, and then things moving this way. Kind of cool, huh? Kind of neat. All right. would its reflection show realistically? Yeah, let's put a mesh in there. That's a good question. Okay. My poor computer is just suffering today. What is going on? Yeah, my backup's running. That's what's happening. All right, so let's throw let's exit out of that for now. Yeah, let's throw an object under there. Let's put a chair or something. Starter content, props. Put a table under there. Scale it up a little bit. End to snap it down and play. So let's see how this works out. So you see how the table, like you can see the refraction as the waves kind of move over it. Is that coming through to you guys? Yeah. Pretty cool. And then when we're underwater, there's no refraction, right? But we're getting this film grain effect, and we're swimming because I put a physics volume down there. And if I can get up above the surface again, you can see that as the normal map has waves, simulating waves on the surface, you can see the refraction of the table changes. And even though that took me like, I don't know, a few minutes to do, like it's not bad. And I'd want to do things like this is too shiny right up there. So I'd want to play with that. I'd play with the Fresnel effect so that it's not like super shiny like that. So that looks a little bit unrealistic. And the opacity I'd probably play with as well, but that's a good starting point. And so what we got here is two different panner nodes. One, you can see one of the panners is moving the white highlights towards me, right? You see how there's like that pattern of white moving towards me? And then I have another panner node that's at a 90-degree angle to it. Again, not exactly accurate, but whatever. And that's moving the other pattern left to right in front of me, or right to left in front of me. And it's also moving the normal map. The normal map is moving in that direction as well. And so realistically, I'd want to have the normal map blurp also. And so the waves would actually reflect both of them. And so you'd get this neat reflection pattern. But that's good enough for now. I do want to move on to landscaping. Okay. So, you can see the sun reflecting off of it, and it's kind of cool, dude. Like, I don't know. Like I said, that's the shininess, because we started with glass, right? The shininess is a little bit too high, and I'd want to play with those, but that's a kind of a neat effect. Yeah. And that's using caustics. So caustics are the water patterns, the water light patterns of water called caustics. Okay, so let's talk about landscapes. So one really important thing that I should mention for landscapes is that you don't want to do your landscapes like this. Like this just looks like very 1990s video game-esque, right? Just you have a single landscape that you kind of spray painted around and have a single texture on the whole thing. Like it looks super lame, right? And so a better way of doing landscaping is to actually edit the landscape in like a professional landscape editor and then import the height map. Because remember, landscapes are just a 2D texture. Like it's just a black and white image. The white areas are the max height and the black areas are the min height. And you can actually import mountains and things like that. So I don't know if Zach has height maps in his toolbox as well. But I'm going to go ahead and save all of this, and I'm going to create a new level because I don't want to break this. I'm going to create a new level, and I'm going to call this default, whatever. And if we hit play, we're just on a platform in the middle of the void, and if we fall off the void, not especially interesting, right? So if I mouse wheel up, I can move faster. Okay. Where do we go? Here we are. All right, scroll down to, right, still a little fast. Yep. Okay, that's good. So, let's do landscapes again. Shift 2 for the landscape tab, and texture stream pools over the budget. I got nothing in this world, dude. This is a blank, empty. What the hell? Hold on. Streaming over budget. What the hell are you talking about, dude? All right, this will be called map level 2, whatever. And we'll save this in bill. So until I get too many assets, I just put everything into a folder so I can find all my stuff. Okay, so the landscape's actually going to come above the starter zone. You see that? So when you go into the landscape generation tool, it puts a little green grid where the landscape's going to be, and so this would actually cover up the world. So I'm actually going to lower the location down a meter, down 2 meters. Let's see. Down 1 meter. All right. Or you can drag this, I guess. It's right at the thing. Okay. Cool. And I'll make the ground poured concrete. All right. Okay, so save current world. And so when we are in our landscape tool over here, you can see that there is a option for import from file. And so it says right here, landscape editor, yeah, probably do that. We need a height map, okay? And so let's just see if we can Google up a height map. Zach, oh, Zach not here? He left, that's why. Okay, UE4 height map file. Let's see if somebody just posted something really fast. That looks cool. Yeah, let's see. All right, view image, save. Is this going to be in the right file format? That's a good question. Open. It opens PNG files. Yeah, that's the wrong file format. Let's see. Save as. Can we convert it? No. So we need to convert this to PNG. All right, I'm going to pause this. We're just going to find a height map real fast. Okay, one quick Googling later, and we found a raw file that holds height information. And let's see, is this going to be, where is this going to be in relation to us? Are we going to be floating in space? Let's see here. Let's see if we can make more detail on this. Seems like we're about to get buried, isn't it? See how this works out. And landscape materials, if they're not done properly, they, ew. All right, this is not great. Yeah. Landscape. Yeah, that did not import correctly. All right, let's not do that. Okay, well, let's just go back to the previous level. We can find another. We can find a good place. Starting up. You see how they have a panner on there, and you see how they have different patterns on it. So they have one moving this way and one moving this way. And then on this one, you can see there's more high frequency noise moving this way, and then the right. Okay. All right. All right. Where was I? Yes, this is in first-person blueprints, first-person example map. All right. So there is our water that we made, and kind of proud of it. All right. So anyway, so with landscapes, what you really want to do is probably just find a height map that somebody's made that's similar to what you want, with like beautiful cliffs and all this kind of stuff. And there's tools that generate those things as well. This will do for now. Okay, so what we want to do is make a new material. So I'll go into the bill section here. We'll call this material. We'll call this landscape mat. And so this is going to be the material for the landscape. And let's see here. Here. We're on grass right now, I think, right? So, no, we're out of time already. Okay. So, So what you can do is you can create a layer blend that will allow you to have different different layers on your landscape. So minimize this and come over to the landscape over here. Okay, and so let's get material on here, and come into the landscaping tool here, and what you can do is create. Let's get materials override. What you can do is add new layers to it, but we don't have time to do this. So the general process, though, is you create new layers, and then your landscape material node has a blend node that will blend between them. And what you can do after you've set those things up, and I guess I'll just have to show you guys next time, is you can actually paint on the landscape the different layers. Yeah, we need to assign it a weight blended layer here. And here, and here, and then once we get that set up, then you can just basically use a spray paint tool, and you can actually spray paint concrete onto the map, or rocks, or dirt, or whatever you want onto the map. But yeah, it's good enough for today. So I'm not going to make you guys make a water material. The big thing coming up, the big project is the board game, and so you guys are going to have to get onto Tabletop Simulator, make a board game. They're basically implement the board game that is in your proposal, and we're going to play it on Tuesday, and you guys are going to get to see and maybe play some of the games that the other students made, and that will be kind of the capstone for the game design element of this class. We've talked a fair bit about principles of game design, and this is going to be an opportunity for you to show off that you understand the principles of game design. So you're going to have to make a game that's good. Okay, not like it has to be AAA quality, but it's got to be a good game. There should not be degenerate strategies. There should not be one choice that always dominates all the others. It shouldn't just be luck-based or random-based. It should have, you should be showing off some sort of core mechanic that is fun. And that's really what makes and breaks a game, is that the core gameplay has to be fun. Like Pokemon Go is not a very good game. In fact, it's barely a game at all. Pokemon Go, you just basically walk around and collect Pokemon, and that's it. It's an exercise app more than anything. It's a step tracker with a fancy interface. But the core mechanic of Pokemon Go is you're playing skee-ball. And so when you catch a Pokemon, there's a circle, a decreasing circle, and your goal is to spin a Pokeball and throw it in a curveball so that it intersects this ever-decreasing circle, and it's basically skee-ball. If you've ever played skee-ball at Dave & Buster's or something like that, that's the core game mechanic, and skee-ball is fun. And so Pokemon Go is a fun game, despite there being almost no point to capturing Pokemon out in the wild. They're all terrible. All of the best Pokemon are in raids, and raids cost $1 per raid to do, and you have to have a group of people together to do them, and so basically nobody does them, at least not in Fresno. There's probably groups that do it, but for casual players, like, nobody gets to get the best Pokemon. They just walk around and collect trash Pokemon all day and call it a day. It's really not a good game, but the core mechanic of Pokemon Go is skee-ball. There is a target, and you throw a ball at it and hit it, and so that makes the game bearable, right? It makes the game bearable, even though the rest of it's kind of trash. So, that's what you guys need to be focusing on. Like, is the core game fun? Is that core mechanic, whatever it is that's your selling point for your game, is it fun, right? Rivera, last semester, he had a game where it was involving flicking things, and so basically you had different blocks. So you had a certain amount of money, and you could buy basically different blocks, and you'd set up these blocks on the virtual tabletop, and you had a little flag, and then the core game mechanic was just flicking marbles at your opponents. So you'd have a little rubber band and a ball, and you'd flick the marble at your opponents, and it would hit the blocks, and the blocks could have different densities. The more expensive ones were heavier, but you could build these little castles, and you could flick marbles at them. And the core mechanic was actually pretty fun. He actually did a pretty good job on it. The trouble is, the amount of money that you were given to buy stuff allowed you to buy 3 blocks. And so you didn't get that fun process of establishing a castle and things like that, because you didn't have enough money, right? And then and so when they upped the amount of money, and you could build a little fort, and then you could flick things, it became a very chaotic game where people were just sitting there flicking marbles at each other left and right, trying to knock down the walls protecting their flag, and then you knock the flag over, and you're like, yes, I won. And that was a very interesting game, and it was more possible in Tabletop Simulator than in real life, because in real life there'd just be marbles flying everywhere and getting lost and getting on the carpet and people tripping on them, and the setup and teardown would be really annoying to deal with it. But in Tabletop Simulator, you just sit there and build a little castle out of blocks, and then everyone has the castle building phase, and then when you say go, you just sit there and just shoot little catapults of marbles at each other, and it was a fun game. And probably with some refinement, it could even be a commercial game, right? Because there's something fun to castle building, and there's something fun to destruction. Just wanton, hurling things at things and having them fall over. That is the reason people like Angry Birds. Angry Birds is basically castle destruction. You just fling birds at things, and they topple and collapse and things like that. There's a video game called Forts, in which you build a castle hanging off the side of a cliff, and you shoot howitzers and things like that at each other, blowing up each other's forts. And it's I don't think it's very well implemented, but it's kind of a fun idea. And games like that where you construct things and destroy things. It's kind of a fun mechanic, and so that that hook, that core fun is what you really need to be focusing on. And once you've got that, then you need to think about, are there any degenerate strategies, or is there any strategy that will always win, or is there a strategy? Are there options in the game that just don't make any sense? And you need to refine. You need to refine your design based on that. And if you have to change your game design document, that's fine. Just email me and be like, hey, we're not. As it turned out, this was a dumb idea. We're not going to do it, and I'll say okay. But basically, you're going to be graded on if you did what you said you're going to do. So it'll be a good assignment for you, because there are people whose job it is just to do this kind of stuff. Like, they're game designers. They're not game programmers. They're not publishers. They're not director. They're the people who come up with the core game mechanics. And I'm friends with some of them, and that's what they do. They try and come up with these fun mechanics that will get people like, oh man, that's neat. That's a well designed, well thought out idea. So you got to come up with the idea. You got to execute it. All right. So that will be on Tuesday. And in the meantime, don't worry about this material stuff. I just wanted to show that to you. And yeah, I'm kind of happy with how it turned out. The super shiny reflections over here, kind of want to fix for next time. And then we'll move on to landscaping next time and show how to. There's a few more steps that I didn't do because we ran out of time. So we'll do that. We'll do that next time, and then you'll be able to spray paint landscapes. And if we really get cool into it, you can actually make it so when you spray paint an area, flowers grow on it and stuff like that. So you can actually have the landscape kind of generate clutter and flower foliage and things like that too, which is also pretty cool. Okay. So that will be next time, people. In the meantime, work on your board games, and good luck. I'll see you guys on Tuesday.